All right, so hey, I'm Rob Emanuele. I lead up the engineering efforts on the Microsoft Planetary Computer. I'm also a member of the STAC PSC. And just quickly, what I want to talk about today is, I think I might, excuse me. Yeah, so the Planetary Computer it provides a data catalog. We have about 40 petabytes of data sets. They are mostly completely openly licensed. There's some non-commercial use license in there, but we use STAC and the STAC collection license field to catalog all of the specific license for each of our data sets. We also provide an API that enables a spatiotemporal search of those data sets, and then something called the Hub, which is a hosted Jupyter Hub environment with sort of the Pangeo implementations of the environment that you'd want to work with, these open data sets, and a few other toolings to make it easy to integrate with our authentication and with the Planetary Computer. And so today I really want to talk about just the parts of the cloud optimized or the cloud native geospatial stack that we're using. It's a little bit of cloud native geospatial stack bingo. And it starts with the data storage and serving, right? So all of our data is stored in blob storage, in Azure Storage Blob containers, which provides scalable cloud access and allows the byte range read capabilities that are sort of the linchpin for cloud optimized formats. We also have this shared access signature mechanism for creating short to long-term permissions on storage accounts, containers, or individual blobs, which allow us to sort of sign URLs and allow them to be used with the GDAL and the rest of the tooling as if with just HTTPS. So we store a lot of data in cloud optimized GeoTIFF, right? That's our preferred format. I think cloud optimized GeoTIFF is one of the original, if not the original, geospatial data format that took advantage of the byte range read requests. And so when the chunking, our sort of rule of thumb, we've had a lot of discussion of like, okay, when is it COG? When is this something like ZAR or NetCF? When chunking is long space and not a long time, if you have multispectral imagery, not necessarily something that is like would need bands that represent a time axis, those are appropriate for COG, and with that, you get a lot of sort of current tooling that's pretty advanced as far as visualization and other work. We keep things in the original CRS, no reprojection as part of preprocessing. We rely on dynamic reprojections to do that sort of stuff. We just use the default overviews in GDAL, like GDAL translate output format COG, so that's usually a pretty good default to use, and a ton of examples of data sets that use COG. So the way we visualize COG, we also, we supported the development of PG Stack, T-Tyler PG Stack, that sort of stack of tools, and so that's what we use to visualize our front end. The front end that we have, the Explorer tool, if you go to planetarycomputer.microsoft.com, go to Explorer, all of that is powered by the STAC API with some render configuration per collection. We have sort of default queries and min zoom level and some of the things that aren't stored at the collection level, but mostly it is powered completely by our STAC API. Supports dynamic legends. There's a multi-layer support that we're releasing soon. It allows you to copy your stack query as code using PyStack client so that you can use it in the hub or any other Python environment. We use T-Tyler for rendering and the T-Tyler PG Stack for dynamic mosaics. So you can do arbitrary searches against the Stack API, and then those get rendered dynamically as long as it's a cloud optimized GeoTIFF data set. And you can do things like, compute false colors and NDVI and things like that on the fly. Other formats we use are ZAR, which is efficient cloud access for higher dimensional data sets, really good for regular gridded data, traditionally captured in things like HEF, NetCF. It's a quote unquote newer format, right? It's been around for a bit, but it's language agnostic, but the tooling is not necessarily complete, for example, in the R ecosystem. And then we have data sets like iMerge and DayMet in the ZAR format. Another sort of even more new technique is this idea of cloud optimized netcdf. We don't really have a good name for it. I'd like a good name for it, but so it's the tool called kerchunk that builds up these index files that index into an existing set of netcdf, hdf, or grid files even. So you need to do some pre-processing and create this external index file, but then it allows for cloud optimized reads into the data cube represented by many netcdf files. And this is beneficial because of the pattern of using standard, well supported data formats. So like GeoTIFF is well supported, and Cloud Optimized GeoTIFF uses, Cloud optimizes that existing format. Things like, LAZ to Cloud Optimized Point Cloud. This is sort of continuing that pattern of using the well-known formats and then building a cloud optimized format of that. However, it is a newer tool. The tooling lacks maturity. It's only Python for now. Would love to see this as a mature into a full-fledged alternative to cloud optimized formats for multidimensional data. And so examples of what we're hosting, we have the next GDP CMIP6 data set as Cloud Optimized GeoTIFF, and that allows us to not have to, transform that entire data set to a Azure data set, modifying the data set in the process. We sort of want to keep it as NASA published it, but then build on top this index into those data sets to allow for Cloud Optimized access. Another data format we're supporting is Cloud Optimized Point Cloud. We support a lot of the tooling development of this, and we're excited to release our 3-depth LiDAR, which is going to be in Copic, and then also have derived elevation products in cloud optimized GeoTIFFs like height above ground and various other elevation products based off of that. But yeah, it's a cloud optimized version of the popular LAS file format. So again, it allows for people who are using sort of an older set of tooling or non-cloud optimized aware set of tooling to read the data and not be shut out from that, but then enable smart clients to read that data as well. And then also we support, Parquet and GeoParquet, right? So this columnar format, good for tabular data. It's really good for analysis. There's a lot of great tooling in the ecosystem around it. And so the GeoParquet is a newer format. I'm sure it's being talked about a lot. Enables spatiotemporal filtering with correct partitioning. So you have to kind of set it up right, but then you're able to, from the flat files, actually do filtering on vector data, which is really great and enables a lot of unlocks a lot of analysis. So for instance, we host US Census population, which is Parquet, just tabular format, and then the US Census blocks with the polygons are actually in GeoParquet, and you can join those. And there's just examples of how to do that on our site. And then of course, we're using STAC as sort of the core metadata store and API for everything we do. So it is at the core, the data sets are processed to extract STAC metadata and then transform the cloud optimized formats when needed. And I say when needed because more and more we're seeing data already appearing in cloud optimized formats, and we love that because it kind of starts from the data producer in cloud optimized formats. We don't have to introduce our own processing. We want to leave that all to the data producers, but we do it when necessary. And our stack is stored in a PG stack, and the Stack API is through StackFast API and the PG stack backend, similar to other folk. And so last point I'll make is just like, yeah, we've seen this architecture in a couple different places. From our side, our users and our customers more and more are coming to us with demanding these formats and this stack to build out geospatial solutions. So I think it's fair to say that the cloud native geospatial stack is becoming an industry standard for building scalable solutions using geospatial data, and that's certainly something from Microsoft perspective we're going to keep leaning into to provide solutions to our customers. Thank you.
Awesome. Thanks so much, Rob. You want to stop sharing your screen? And then if we could get Ian on and over to his shared screen sharing. But yeah, thanks, Rob. And yeah, I think it's worth sharing with everybody. Microsoft, they're using all this stuff, but they have been a huge force of maturing a lot of this stuff. So they've touched all of those projects invest in a big way. And I think it's a good example of a company not just using it, but kind of seeing that future and really supporting the projects to make more and more happen for their users and their use cases. But as Rob said, it sort of circles back into their users then demanding this and has a really great virtuous cycle.